All right, we're back with part 2 of your practice midterm. So question number 17 asks us to simplify using the order of operations. So quick reminder, here's what we're using: grouping, exponents, multiply and divide from left to right, add and subtract from left to right. So here's our problem: 27 minus 3 plus 4 divided by 2 times 3 to the second. We don't have any grouping in this problem, so we are going to start with our exponent, 3 to the second. 3 to the second means we're multiplying 3 by itself 2 times. So 3 times 3, which is 9. Now our next step, we finished our exponents. Now we multiply and divide. But we have to do what's ever on the left first. So I see division, I also see multiplication. But because our division is on the left, we're going to start with that. So 4 divided by 2 gives me 2. And everything else I'm just going to write the same. Now I have subtraction, addition, and multiplication. So I'm still on this step. Multiply and divide from left to right. So I'm going to do 2 times 9. 2 times 9 gives me 18. So I have 27 minus 3 plus 18. So I have subtraction, I have addition. I add and subtract from left to right. So on the left, I have this subtraction. 27 minus 3 is 24 plus 18. I'm going to set it up over here vertically so we can see it a little better. 8 plus 4 gives me 12. Carry my 1. 2 plus 1 is 3 plus 1 more is 4. So 24 plus 18 gives us 42, which is answer choice A. All right, number 18, our explicit definition of our arithmetic sequence. Here's our equation. Now remember, we can also write the D in front of the parentheses, same thing. So it wants us to actually write one of these equations for this sequence. And right here, they're telling us A1 equals -2. That's just our first term in this pattern. So our A1 right here, first number, needs to be -2. So we can automatically eliminate answer choice C because that says +2. And answer choice B because that says 3. Now the only other difference here is our D value. Our D is our common difference. So it's the pattern that we're going by. And if I look, I'm going to look at my positive numbers here. To get from 7 to 10, 7 plus 3 is 10. 4 plus 3 is 7. 1 plus 3 is 4. -2 plus 3 is 1. So that common difference that we have should be 3. So our equation, it might help us to write it first and then be able to eliminate. But our common difference, the only one of the two we have left that had a common difference of 3, is answer choice A. All right, number 19, we have an inequality, and we need to figure out which graph is our solution. So we've got to solve this inequality. This is one of our and problems because we don't see the word or, and it's written as one big problem. So here I'm going to draw my 2 vertical lines. I'd normally draw one when I solve an equation, but here I kind of have 2 signs in it. So whatever I do to one section, I have to do to all the sections. So I'm going to start in the middle, and I'm going to have to subtract 6, and I do it to all parts. Now, -2 minus 6, that is going to be the same as adding a -6. Minus is the same as plus and negative, so that gives us -8. And 6 minus 6 in the middle gives us 0. 12 minus 6 is 6. So my next step, this is 2 times x, so I'm going to do the opposite of multiplying by 2, and I'm going to divide all 3 parts by 2. -8 divided by 2 is -4. 2 divided by 2 gives me 1x, or just x, and 6 divided by 2 is 3. Now, x is somewhere between -4 and 3 inclusive. It's including those numbers. They work. So this is going to be one of these type of problems where it's connected. So we can automatically eliminate answer choice C and D. Now, all these are on the same number, so let's look at the differences. These both have the equal to part. When they have the equal to part, that means our circles are going to be closed. Okay, whoops, I appear to have copied something wrong. So I'm looking here, I don't see one where both are closed. So that means I made a mistake somewhere. I need to go back and look. And if I see here, this one was not equal to begin with. So this is not right here. So that one actually should not be closed. And that's a good way to kind of check your answer at the end. Something wasn't right. So that actually doesn't have the equal to part. So that one should be open. So on the left, we should have our open circle. On the right, we should have our closed circle. And that only matches answer choice B. Left open, right closed. All right, number 20. This one wants us to look at the equations and figure out which one has no solution. So really to do this, the good idea is to solve each of them. So I'm going to move up here for part 1 since I have some room. And I have 2 times 2x minus 1 plus 7 equals 2 times 2x plus 5. My first step is going to be to distribute here. And really here, that's not quite distributing, but it's multiplying. So 2 times 2x is 4x. 2 times negative 1 is negative 2. And on the right, 2 times 2x is 4x. Now on the left, I need to go back and combine my like terms. So negative 2 plus 7. That's really the same as 7 minus 2, which is 5. Notice here you have the same thing on both sides, so that's kind of a hint. But I'm going to subtract my 4x from both sides. And that just leaves me here with 5 equals 5. That is a true statement. If it is a true statement, that tells us it is actually infinite solutions, not no solution. So I'm going to write that near answer choice 1 there. That's not going to be my answer, so down here I'm going to cross out A. Now I'm going to work out each of these until I find my one that's right, but then I'm still going to check my others just in case. So number 2, I have 3x plus 8 equals 2, 3x plus 2 minus 3x. So I'm, again, going to start by distributing here, because on the right we need to distribute. I'm going to take that 2 and multiply it by each of those terms. So 2 times 3x is 6x. 2 times 2 is 4. And now on the right, I'm going to combine my like terms. 6x minus 3x. 6x minus 3x gives me 3x plus 4. So then I'm going to subtract my 3x on both sides. And that leaves me with 8 equals 4. That is not true. So that should be our answer. That should be our no solution. But let's go ahead and check at least part way. Answer choices 3 and 4. We might know without having to go all the way through it, but we still need to give that a shot there. So again, that was answer choice 2. I think that's right. All right, so answer choice 3 here. I have 8x minus 2 equals 2 times 4x minus 1. So I'm going to start here on the right and distribute. So I have 8x minus 2 equals 8x minus 2. Hey, look, I have the same thing on both sides again. Likely, we should be able to tell our answer from there. But just in case you're not totally sure yet, we can go ahead and subtract our 8x from both sides. And those cancel out. They subtract and give us 0. So we're left with negative 2 equals negative 2, which is true again, and that is infinite. So if you're noticing it's the same exact thing on both sides, even at this step, you automatically know it's going to be infinite number of solutions. Let's check answer choice 4 here. So here I have 7 parentheses x minus 3 equals 2x plus 3 minus x. And I'm going to start and I'm going to distribute. So that leaves me with 7x minus 21 equals 2x plus 3 minus x. So on the right side, I've got some like terms to combine. So let me write this. 2x minus x just gives me x. Notice the variables are not the same on both sides. That's also a clue. But I'm going to go ahead and subtract the x from both sides. 7x minus x gives me 6x. X minus x gives me 0. I'm running out of room here, but we can make this work. I'm going to add 21 on both sides. And I get 6x equals 24. Divide both sides by 6, and I get x equals 6. If I get an answer like that, that means there is one solution. Our answer is 6. That's our one answer. So going back, our answer of 2, which is answer choice B, is our correct answer. All right, let's continue on. We're going to continue on with question 21. All right, we're going to continue on with question 21. So question 21 is asking us, what is a reasonable domain? We don't actually need to worry about that word reasonable here. Usually that will deal to kind of real world situations. But we do need to worry about domain. Domain, again, those are your x values. So we're asking for x values, and remember, relation is just a group of ordered pairs. So let's look at what these ordered pairs are in order to figure out the domain. So ordered pair A, we're going left 2, so that's negative 2, and then up 1, 2, 3, 4, 5, so it's 2, 5. B is at our origin, which is 0, 0. C is 1, 2, 3, 5. And then answer choice D is at 4, 5. So remember, in ordered pairs, the x comes first and then the y. So we're looking at that first number in each of these, the x value. So all these numbers right here. And typically when you see these, they are going to be written in order from smallest to biggest in our set notation. So our smallest is negative 2, then 0, then 3, and then 4. And that's going to match here with answer choice C. Now 22, similar problem, but this time it's asking for the range, which is your y values. So again, we need to look at our ordered pairs. And one strategy I'm going to use as I go through these is to cross them out on my graph. That way I make sure I don't use them more than once. So I'm going to start with this one. This one is 1, 2, 3, negative 3, negative 2. So I'm going to mark that out. This one is negative 2, 0. Then I have 0, 1. And then I have over 2, down 1, so 2, negative 1. And then over 4, up 3, so 4, 3. That's a really good strategy you use of marking them out just so you don't accidentally use one more than one. Quick reminder, x is first, then y, so we're looking for the range, your y value, those second numbers here. So when we look at this, let's put them in order smallest to largest. So negative 2 would come first, then negative 1, then 0, then 1, and then 3. So those are my range values here. So negative 2 should be my smallest, which is not the case in A. A has negative 3, so we know A is not our answer. They all have negative 2. They all have negative 1. They all have 0. They all have 1. And this one has 4 instead of 3. That has 3, but this one has a 2, which is extra. So by process of elimination, our answer choice is B. All right, number 23. This is a literal equation problem. The formula for volume of a rectangular prism is found by multiplying the width, length, and height of the prism. In other words, V equals LWH. So that is an L, just kind of a cursive L, so it doesn't look like a 1. So it wants us to solve for W. So V equals LWH. And we're being asked to solve for W. That means just to get W alone. Now, on this side, L, W, and H are all being multiplied together. The commutative property of multiplication tells us we can change the order of multiplication. So I can write this as LHW if I want, which makes the W look a little bit separate. So you can kind of think of it as kind of separate pieces here. So if you look at it, this L and H are being multiplied by W. Well, the opposite of multiplying is dividing. So I'm going to divide both sides by LH because that's the opposite of multiplying. So LH divided by LH gives me 1, or 1W. And over here I have V over LH. So here, the only one here with the fraction is answer choice D, so we need to check that. V is on top, L times H is on bottom, so our answer is answer choice D. All right, number 24, we have another one of these compound inequalities to solve. I better keep my signs straight this time and not mix those up. All right, so remember, whatever I do with one part, I have to do to all the other parts, so both other parts. So in the middle, I want x alone. My first step is subtracting 4. So on the left, 4 minus 4 is 0. It doesn't mean I don't put anything there. I have to write the 0 there. That's a part of it. 4 minus 4 is 0. And on this side, 8 minus 4 is 4. Now I have to divide by 2. Since the x is being multiplied by 2, I'm going to do the opposite and divide. 0 divided by 2 is 0, is less than. 2 divided by 2 is 1, so I have x. And 4 divided by 2 is 2. So here, let's make a note about our signs. This is our less than sign. There's no equal to part. That means that 0 is not a solution, so that should be open circle. This less than or equal to is got the equal to part, so that means the 2 is a solution, so that is going to be closed. So on the left is open, right is closed. So A has the closed on the left and the open on the right, and it's also on -4 and 4, which are not our answers there. We need one that goes from 0 to 2. This goes from -4 to 0. This goes 0 to 2. This goes -2 to 0. So the only one that's actually matching with those numbers is answer choice C. All right, number 26. Which of the following relations, so remember a relation is a set of ordered pairs, is not a function? So remember, a function, our x values don't repeat. And if they repeat, they have to be with different y values. So let's go through. Okay, and one very important word here is not. So you got to be careful of those words because that's the difference in getting it right or wrong. So answer choice A, 1, 2, 3, 4. There are no x values repeating there. That is a function. Answer choice B, 2, 4, 6, 8. Nothing repeating. That's a function. Answer choice C, -2, -1, 0, 1. Nothing repeating there. That looks like a function. So I'm thinking it's answer choice D, but let's be sure. Answer choice D. Oh, there's 2 1s. There's also 2 2s there. So we've got we've got our x values repeating with different y values. So that one's paired with a 4 and with a 5. Now, these 2s actually don't matter because 2s with 6, 2s with 6, that's just a repeat. Okay, it's almost like an error there. If we graphed it, it's the same point. But those 1s paired with different y values, that makes it so it's not a function. I appear to have skipped question 25 somehow, so I'm going back to that. Not sure what happened there. So number 25, it wants to know what is the value of this expression if x is 4 and y is -3. So I'm going to rewrite my expression, but every time it has a variable, I'm going to put parentheses. And my x is 4, so that 4 is going to go where this x goes. My y is -3, so that -3 is going to go where the y went. So now we need to simplify. Order of operations. All right, writing that out. We don't have any grouping here. The only reason we have parentheses is just kind of separating off those numbers so we could plug in our variables. So we do have to work with our exponent first. So here I have 4 squared. 4 squared means you're multiplying 4 times itself 2 times. So 4 squared really means 4 times 4. 4 times 4 is 16. Now, we do technically have a grouping symbol in here. That fraction bar is a grouping symbol. So realistically, we need to simplify the numerator and then simplify the denominator and do whatever we need to do after that. So technically, we do have a grouping symbol. So now we have minus, and times here. So according to order of operations, we multiply before we subtract. So this is -4 times -3. And negative times a negative gives us a positive, and 4 times 3 gives us 12. So continuing on, simplifying that numerator, 16 plus 12. I'm going to write that to the side so I can make sure I add it. 6 plus 2 is 8. 1 plus 1 is 2. So it's 28 over 2. 28 divided by 2. 2 goes into 1. 2 goes into 8, 4. So 28 divided by 2 is 14, which is answer choice D. All right, now we're skipping back to number 27. Again, not sure how I missed that one before. This is one just like it though. This is a substituting problem. We have to fill in each of our variables, our numbers for our variables. Now, A is 3. So A is just right here. I'm going to fill in 3. Notice there are 2 spots for this B to go though. So -1 and -1. So we're going to follow the order of operations. Again, we do exponents first. So this is -1 squared, which just means -1 times -1. A negative times a negative is a positive. That minus is still there because that was subtraction in this problem. Now, order of operations tells us we are going to multiply before we subtract. So 3 times -1 is -3. And right there I have -3 minus 1. Remember, minus is the same as adding a negative. So this is really -3 plus -1, which is -4. And that right here is answer choice C. Okay, number 28. We are being asked to state the range. Now, remember range, that is our y values. Now, the only time you're going to have an answer that looks like D is if you have just ordered pairs plotted on your graph. This does not have ordered pairs plotted on our graph. It's got this line segment here, so answer choice D is not going to be our answer. So, because we're looking at range is Y. Notice all my answer choices do have Y's in them. That's good. There's no X's, because if there are X's, that would not be the answer. When we're looking at our range, we go from bottom to top. And I only look at this line segment here. So I'm starting here and moving from bottom to top. This goes from -2 all the way up to +2. So my y values for that particular line segment are going to be between -2 and +2. The only one that shows that is answer choice A. Y is between -2 and +2. All right, number 29. Mary compared the slope of this function, y equals 5x plus 6, to the slope of the one below that's going through these points. So we're making comparisons. This is a really common type of EOC problem. They like to have you find the slope of 2 different things and then do something with those. So let's talk about the slopes first, and then we'll get on to what this question is actually asking. Well, this one, our slope is our number right by our x. So this has a slope of 5. This one, we need to find the slope. So we could do it in a couple different ways. We could look at the rate of change on our table. So we could do our change in y over our change in x. So let's look at that. From 3 to 6, that goes up 3. 6 to 9, that's up 3. 9 to 12, that's up 3. So this is all on the y side, so our change in y is 3. On this side, our change in x, 1 to 2 goes up 1. 2 to 3 goes up 1. 3 to 4 goes up 1. So our change in x is 1. So therefore, 3 divided by 1 is 3. The other way to do it would have been to choose 2 points. So 3, 9, and you could choose any 2 points there. And 4, 12. I'm just going to look at these two. I'm going to do my x for my first, my y for my first, x for my second, y for my second. And I can find my slope using the slope formula. y2 minus y1, x2 minus x1. So if I plug that in, y for my second, oops, this should be a y. Y for my second is 12, minus my y for my first, which is 9. X for my second is 4, minus x for my first, which is 3. 12 minus 9 is 3. 4 minus 3 is 1. 3 divided by 1 is 3. Same slope. Okay, so this is our slope for our second one. Now, here, the question actually asks, what is the difference between them? Difference is another word for subtraction. We're finding out how far between the two slopes. So that means we had to find the slope of one, had to find the slope of another, and now we're subtracting. So the slope of the first one was 5. Slope of the second one is 3. 5 minus 3 is going to give us 2, which is answer choice A. Again, very common type of EOC problem is finding two things and then making some kind of comparison. All right, our last problem, number 30. So here, Kelly solved this inequality, and we want to figure out where Kelly made her first mistake. So where it says given, that's just them showing you the problem. And we're going to go through this problem because a lot of times the easiest way to find the mistake is doing the problem yourself and seeing where it matches up. So our first step, we're going to distribute. So 3 times x is 3x. 3 times 4 is 12. All right, step 1. Whoops, what did I copied the problem wrong. Fix that. So I almost thought she made a mistake right there, but that was my mistake. I copied the problem wrong. So always go back and double check things. Even teachers make mistakes. No big deal. Just try and figure out what your mistake was. Double check everything. So right now they look the same. So my next step, I'm going to combine like terms. I have negative 12 minus 4. So I'm going to write that here. Remember, minus is the same as plus and negatives. This is negative 12 plus negative 4. So I have 3x minus 16 is less than 1. And look, they're still the same. So we know that step 1 is not where she made her mistake. That was fine. Step 2 is not where she made her mistake. That's fine. So I'm going to eliminate those answers as I go to make sure we're getting it right. So now, for the next step, in order to get to this next row, which they're not showing their work there, but we know we need to. So I'm going to add 16 to both sides because that's the opposite of subtracting. And I get 3x is less than 17. And so I'm going to go back here. Oops. And if I compare right there, notice that's where we're different. It appears that they subtracted instead of adding. But we need to do adding because that's the opposite is minus. So right here, step 3 is where they made their first mistake. That is the end of your practice midterm. Hopefully this helps, and hopefully you have a great score on your midterm.